So my name is Dirk Leipold. I'm the CEO of Equal1. We are a silicon quantum computing startup, and the silicon kind of stuff we're doing is really electronic quantum dots integrated with large amount of electronics. And the talk today is especially to try to get interest into an industry consortium to be formed, which is helping with providing isotopically pure silicon. So we are basically trying to build desktop quantum computer platforms. We're doing this today based on commercial CMOS processing. That obviously is limiting the kind of qubit accuracy we can get. So we got our first demonstrator running last year with 95% gate accuracy. And we're now having a hybrid qubit platform, which we're currently building. See a photo here of something we recently turned on. And the idea is really to get all the way to where you might have even personal quantum computers. And we think we can deliver this in a couple more years here. The key thing is that you kind of hold back here in the quality of the qubit gate accuracy, and we're overcoming this by integrating massive amount of electronics. And if somebody's interested in this part of a quantum computer, you're very welcome to contact us on what our machine can do today and how we actually integrated it into a neural network platform.
Set up for now.
You rock.
The second thing which we're having here is that we're basically, because we're using commercial
please mute, Andy.
Because we're using commercial CMOS technology, where we're basically building our quantum dots out of the silicon films available and living with the quality we get and the stability levels we can get. We're obviously using natural silicon, so that's a mixture of multiple isotopes. We also have in this process actually the PMOS transistor as a silicon germanium device, and in both of these things you have a mixture of isotopes, and there are some isotopes, for instance silicon-29, which is actually having a nuclear spin that's coupling to your actually spin in your spin qubit, and that basically muddies the water and basically kills your qubit performance. Now, if you're looking at what that effect actually does to you, you see it here. You basically would have the yellow line if you would have isotopic pure silicon, and if you are stuck with the natural silicon, you're stuck at the blue line. Now you see that there are experiments available where some of these wafers are available today, but there are very few in between and are not available in a commercial CMOS process. And one of the reasons is that all the silicon-28, which is currently used worldwide, actually comes from Russia. I think we all can agree that's not a very beautiful idea. So we actually should get some local resources to get silicon-28 and also the germanium-74 to actually get this isotopic pure performance available to a broader sector of people. And so basically, what we did is that we were getting in contact, and actually obviously we have a beautiful infrastructure in place, especially the Department of Energy has in Oak Ridge Laboratories quite some capabilities to actually make this isotopic pure silicon. And so we have some collaboration with SLAC, which is a DOE lab, and SLAC actually is helping us to get the project off the ground here. And it looks like DOE would be willing to be our sponsor and actually make MPW runs available. So what we contacted so far is Global Foundry says, yeah, I mean, we support this. If we can get our hand on this material, we surely would do an FDX22 run for you, where you actually can have in a commercial process the right isotopic pure silicon. We talked to Soitec, which could provide the semiconductor wafer manufacturing, and they might be a part of the party here. If you have somebody else who can make fully depleted SOI wafer, 300 millimeter, ready for Global Foundry to consume, please contact me. I'm very willing to work with them. Intel says they definitely need the silicon-28 and the germanium-74, and they were talking about that they need in excess of 10 kilogram per year, which is actually a large quantity. IBM was quite supportive. I think there's going to be a lot of people interested. So what we really try to get done here with my speech today is that we set up an email group, silicon28@equal1.com. We would like to hear from you if you are interested in these services. We would like to basically form a strong consortium, and we want to get organized so that we get funding. And I'm pretty sure the way I'm observing this, it will be not a problem to make sure that you can source a silicon 28 wafer as conveniently as you today source your standard silicon if we get this project running with help from the government.
Great, thanks, Dirk. So, wow, you're building a personal quantum computer.
Yeah. Well, if you first demo the system working, I mean, it's not the greatest quantum computer on earth, but it lives within the constraints I have. But because my technology allows you to integrate, we already have 224 quantum dots on a single chip. And we're thinking the production chip we're doing for next year, we're trying to hit the 1 million qubits node on a single chip. And that will be possible because it's relatively easy to scale up. And also because we have this bad silicon, we can temperature-wise work around 3 Kelvin. That allows you to actually have massive integration. So we're working on a chip which would realize a neural network with 100 million weights integrated.